Hello and welcome. Today I'd like to introduce to you the test method for the Whaletech Cmrr 2.0 test equipment. Now the Cmrr test is one of the more difficult tests in the standard, so this video is intended to provide a quick reference for engineers performing the test. There is a separate video covering the theory behind Cmrr, as well as the requirements in the standard and the design of the equipment. This particular video covers the required equipment as well as the test method, some of the variations in the standard, and replacing the battery inside the box. To perform the test, we need the following items of equipment: the Whaletech Cmrr test box and breakout box, a function generator, a battery-operated multimeter with a millivolts AC range, a grounding plate or earth metal bench, and connecting cables. To reduce noise, the main test equipment should be placed over the grounding plate, with the ground of the Cmrr box and the ground plate connected together, as well as the earth of the equipment under test, if available. In particular, any cables should be placed over the ground plate. AC power supplies and cables should be removed from the test area. Connect the function generator to the Cmrr box and the multimeter to the blue and green terminals, and set the multimeter to AC voltage. Set the function generator to the required frequency and then adjust the output until 20 volts RMS is measured between the blue and green terminals. Connect the Cmrr ECG breakout box to the D15 connector. Connect the multimeter between the yellow and green terminals. Leave the function generator connected, but turn the output off. Verify that the background noise is less than 0.5 millivolts RMS. If not, check grounding, cables and other noise sources. Turn the function generator on and use the adjustable capacitor to obtain 10 millivolts RMS within 5%. Connect the ECG under test and move the right arm lead electrode, labelled as RA, to the imbalance terminal. Turn off the function generator and verify that there's no significant noise on the ECG record. Make sure that the ECG under test has the mains or AC filter turned off, as required by the standard. Turn on the function generator and measure the indication on lead 1 or lead 2. Check again with the DC offset set to plus 300 millivolts and minus 300 millivolts. Return electrode RA to the terminal as labelled and connect electrode LA to the imbalance terminal. Measure the indication on lead 1 or lead 3, and again with plus or minus 300 millivolts. Continue this process until all available lead electrodes are tested. Repeat to make sure that all mains frequencies are also tested. The latest IEC standards all test with an impedance in one lead only to create an imbalance condition. Some standards, such as AMI EC13 and the first edition of IEC 60601-2-47, have an alternate configuration where the imbalance is created by having the impedance in all leads except one. This alternate construction can be achieved by using the general purpose ECG breakout box. When it connects to the Cmrr box, all leads have the 51K 47 nanofarad connected to the inner shield except for the imbalance terminal. The standard IEC 60601-2-47 has much lower voltages than the other standards. At these voltages, it may be too low to accurately monitor the shield voltage via the 1000:1 divider. It is recommended to first adjust the divider using an input of 20 volts RMS as previously shown, and then reduce the input to 2.8 volts RMS, or as instructed by the standard. The DC offset is powered by a battery that should last for several years with occasional use. If the equipment is accidentally left on, or is subject to regular use, the battery may deplete. To replace the battery, remove the knob and 4 base screws, then unscrew the nut on the knob shaft. Remove the shield and replace the coin cell battery. The battery type is an SR44. After removing the nut for the shaft, keep the box flat during replacement to prevent the switch from disassembling. Reassemble, taking care to firmly tighten screws and nuts, but not to over-tighten. Check the 300 mV DC offset after reassembly is complete. So that's it. We've covered the required equipment, the test method, some variations, and how to replace the battery in the unit. Just a quick reminder that there is a separate video covering the theory, standards, and also the design of the equipment. And if you have any questions, please feel free to contact Whaletech with the details shown. Thanks for your time.